Hello everyone, welcome back to my YouTube channel .NET Mastery with Tanya. And today we are talking about inheritance, which is the third pillar of OOPS concept. We have discussed about encapsulation and abstraction in my previous videos, and today we will be exploring inheritance. What is inheritance? Inheritance is the mechanism of consuming the members that are defined in one class from another class. From my previous videos, we are aware that a class is the collection of members. So now inheritance says that you can access these class members of one class through another class by establishing a parent-child relationship between the classes. Okay, so this is the syntax, how you will declare a class and then inherit it into another class. This is my class 1, and then you can see this is class 2, which is inheriting class 1. So the syntax is, first you have to provide the access modifier. If you do not provide the access modifier, by default the class access modifier is internal. Okay, so I have not provided the access modifier, so it will be internal. Internal class, then the child class name, that is class 2, then the colon, and then the parent class which you want to inherit. Okay, and you can call this class 1 as the parent class or base class or superclass, and class 2 also can be called as child class, derived class or subclass. Throughout the video I am going to use parent and child for parent class and child class. Okay, now what is the purpose of inheritance? Why are we using this inheritance? See, class 1 can have many methods. Okay, method A, method B, and one way of using the same method into class 2 is simply copy pasting those methods inside class 2. But that way we are going to duplicate the code, and my application size will be large, and we'll have to maintain the code everywhere. Like if I have provided the class 1 definition inside class 1 test method inside class 1 and class 2 both, then if there is any change in that method, I have to make the change inside class 1 also and class 2 also. So inheritance is the solution for all of these. We can declare all the methods inside one class and use it as a parent class inside another class, and can access them easily like its own method. Okay, then what are the rules of inheritance? We'll see them by code also, but let me take you through the theory first. Okay, so parent class constructor must be accessible to child class, otherwise inheritance will not be possible. Why I'm saying that? Let's check the code actually, and that will be more clear to you then. So here I have class 2. See, I have class 1 where I've provided these two methods, which is public, and in class 2 I have nothing written here. But still, if I go here and create the object of class 2, object, let's write, so now if you type this class 2 object and press dot, you can see in the IntelliSense, you can see test1 is coming. The definition, you can see it is class 1 dot test1. That means it is using this test1 which is defined inside class 1. This class 1 is originally registered inside test1, so that is why you can see this. Another is test2, it is again from class 1. So we can use the methods of its parent class as if it is its own method. Obj class2 dot test2. Okay, and I'm going to run this. See, test1 and test2, it is printed. Okay, why it was possible? See, we called the constructor of class 2, but in but in programming in OOPS, when you call the constructor of a class, the execution will start from its superclass constructor. Okay, so if you have inherited class 1 into class 2, then if you call the constructor of class 2, it will first call the constructor of class 1. And if there was another class, another parent class of child 1, it would have called that class constructor first, and then class 1 constructor, and then class 2 constructor. Okay, so as you know, like we have discussed about the constructors functionality in my previous video, but to remind you, if you have not explicitly defined the constructor inside a class, an implicit constructor is provided from the compiler. So we have not declared any constructor here also and here also. So right now the compiler is giving the constructor. By default, the implicit constructor is coming here. But if you define the constructor explicitly, constructor here, let's call the constructor default constructor. I'm going to print console.writeLine constructor from class 1. Okay. Now I have not provided the access modifier here in class 1. So by default, the constructor's access modifier will be private. And if it is private, then nobody can access it, of course. So now you see what happens in the program. Okay. See, it's saying there was build error. Do you like to continue or run the last build? No. What is the error? Let's see. The error is class 1.class1 is inaccessible due to its protection level. You see, we are trying to call the constructor of class 2, but why it is throwing the error here like class 1, where like it is trying to access class 1, because of its protection level it is not able to access. This is the error. This is coming from class 2. Why it is? Because class 2 is the child class of class 1, and if you are calling the child class constructor, the execution will happen first inside class 1's constructor. It will try to call class 1 first and then it will call class 2. Okay, if I make this public now, see, the issue will be resolved. Now I'm going to run it again. So do you see, constructor from class 1 is called first, and then test1 and test2. Why is that? Because this class 2 object is going to access the members of class 1. But if you have not initialized class 1 object, then how will it access the members? That makes sense, right? To use any of the member, you have to first initialize it. So for initializing purpose, what happens is, first the superclass or the parent class object is initialized. For initializing any object of a class, we have to call its constructor. It is that simple. So first call the class 1 and then it will call class 2. Here also if I put public class 2 constructor from class 2. Okay, there is no problem. Now, even if I make it private, there will be no issue because class 2 right now is the child class. It is not the parent class, but okay, I'm so sorry. If I make it private here, private this constructor, then I cannot access it outside the class. That's why this error. So let's revert it to public. See what happened. First class 1 called, then the constructor of class 2 is called, and then we are accessing class test 1 and test 2. Okay. So parent class constructor must be accessible to child class, otherwise inheritance will not be possible. Okay, then the second point is in inheritance, child class can access parent class member, but parent classes can never access any member that is purely defined under child class. What do you mean by that? Let's go to the code again. Okay, here you can see that we are calling this test 1 and test 2, which is present in class 1. Correct? Let's define a method inside class 2 also. Test 3. Method test 3 from class 2. Okay. If I try to access it from class 2, see, we have test 1, test 2, and test 3. See the test 3, if you see the definition, class 2 dot test 3. But for test 2, it is class 1 for dot test 2, and class 1 also is class 1 dot test 1. Okay. So what does it mean? It means test 1 and test 2 are registered inside class 1. But test 3 is registered inside class 2. Okay. But child class can still access this test 2 and test 1 as if it is its owner. It can access it because it belong it these test 1 and test 2 belongs to class 2, but this is its own method. Test 3 is its own method. It is registered inside class 2. Okay, I can easily access it. But if I create a class 1 object, and if I try to access test 1, it will be accessible, test 2 will be accessible. But what if I try to access test 3? See, I do not see test 3 here because it does not belong to class 1. Parent class cannot have access to anything which is purely defined inside the child class. But child class can access any method which is present in the parent class. Okay, you can think of it as your father child relationship. Okay, any property that belongs to a father will, by law, it will belong to its son. Okay, the son can access all its properties. It belongs to the son. Okay, but whatever new property the son is building, the son is acquiring, it cannot be accessed to the by the father by law. Okay, it is a responsibility of the child to take care of their parents, but it does not directly belong to the father. Okay, so the similar scenario is here. The child can access anything which is present in class, parent class, but it cannot access, the parent class cannot access anything which is purely defined inside the child class. Okay, one point to note here, that the any property which belongs to a father can be accessed to the son. This is true, but the child cannot access anything which is private to the father. Like, if the father has its job, if he's working somewhere, it will not belong to the son, because that is a private member of father. That is a private property of father. So anything which is private in class 1, if I make it private, then see, it's giving the error. It will not belong to the child. Then you cannot access it. Okay. Since it is private, you cannot access it outside the class also. But yes, inside the class also you cannot access it. Say for example, here test 2 is private. I can access it easily here. Test 2. Okay. Because it is inside the class. Inside class I can access it. But similar thing if I will try to do in class 2. See, I cannot access it. Because child cannot access anything which is private in parent class. Let's revert it. Let's make it public again. Okay. Then the third point is, we can initialize a parent class variable by using child class instance to make it as a reference. So that reference will be consuming the memory of child class instance. But in this case also, we can't call any pure child class member by using the reference. What does this rule mean? Let's check out in the code. It means that, see, I can create a reference of class 1 reference. Okay, and I'm not going to initialize it. What is reference, by the way? Reference is pointer to an instance. How do you create the instance? You create the instance using new keyword. Okay, now suppose if I am going to create the instance of class 2 instance, okay, is equals to new class 2. What happened here? This is another reference, and here we are creating an instance. This is reference, this is instance. Reference is pointing to the instance. Reference does not have any memory allocated. Okay, so it will only point to a chunk of memory, which is instance. Instance creates the memory. Now, I can easily class 1 reference do this, okay, is equals to class 2 instance. And if I try to access now through this class 2, sorry, if I try to access the methods using this reference, you see I can access test 1, I can access test 2, but I still cannot access test 3. You see, we do not have test 3 defined. So in this scenario also, you cannot access anything which is purely defined inside the child class. Why I told you this is, the moment I am telling you that this is the same instance of class 2 and I am referring this class 1 reference to this instance, you would think that okay, it's the same instance, I can access it through different references, so I can access every methods inside class 2 also. But that is not the case. If you are using the reference, the parent class reference, it can only point to the methods which is already defined inside the parent class, and it cannot access any method which is present in class 2 purely, which is class 2's registration is inside class 2. Okay, from here also you can see. See, you cannot access. I access this, I can run the application. Okay, that's it for today. We have learned about the basics of inheritance. We will have another upcoming videos on inheritance. Please stay tuned for a better understanding and deep knowledge of inheritance. I'll see you in the next video. Till then, bye bye, and please like the video, do the comment, and press the bell icon if you like it. Thank you so much.